we are discussing the mean value theorem. We are saying that for any function f of x that is defined over a closed interval a to b, if there exists a point c over the interval ab, so that f of c is equal to capital F of b minus capital F of a divided by b minus a, then f of c is the average value or the mean value of x. Now, this component f of b minus capital F of a is the same as integral from a to b of f of x with respect to x. So this is the same as area under the curve, okay, between boundaries, between bounds a and b. So in other words, between the limits a and b. That's what we're talking about. Meaning that the average value of f of x will therefore equal to 1 out of b minus a times integrating from a to b f of x dx, or integrating f of x from a to b, okay, of f of x from a to b with respect to x. What does that mean? If I have a function, for example, a function like this. So if this is a and that is b, this is f of x, this is x. Now, we'll see that this is the area equal to integrating from a to b of f of x with respect to x. Then b minus a is equal to the length of the base of this area. So that means, therefore, that the average value of a function will always equal to the area, okay, under the curve, that is under the area the function is going to cover between maybe x values, x is equal to a to x is equal to b, divided by the base length or length of the base. So that's how we can get the average value of a function. So examples. So we are told to determine the average values over half cycle of the periodic waveforms that we are going to see below. The first one is here. We have a triangular waveform. So over the first half half cycle, because the cycle starts from 0 and ends at 4. Otherwise, it would now start again, rise, fall, like that. So here you will see that the period is actually 4 milliseconds. If you were asked to look for the period, this would be 4 milliseconds, because the period is the time taken by one complete cycle. So half a cycle is from 0 to 2. So now, if we are to look for the average value for one half cycle, then we are going to look for the area under this first, the area under the curve from 0 to 2. So what is the area there? Area will equal to, here it was given as 2. So the amplitude is actually 2. So amplitude is equal to 2. If we were asked to get the frequency, then frequency would be 1 out of 4. And then you would have this would be 1 out of 4 times 10 power negative 3 because this is in milliseconds. Now, area, since that's our major focus, our area is going to be a half base height. Because this is a triangle or it is triangular in shape, it will be a half base height. The base is from 0 to 2, so that will be 2. But remember, it is in milliseconds. We shall multiply by 10 power negative 3. Then the height is in volts. So times 2 in volts times a half, because we have a half base height. So for that matter, we will remain with the area here will be 2 times 10 power negative 3. And this is in volts second. Yes. So if that is the case, let's look at the average. So what is the average? Average value will be area, okay, divided by length, or area under curve divided by length of the base. So the length of the base is 2 minus 0, which would give you, so 2 times 10 power negative 3 divided by 2 minus 0 times 10 power negative 3, because that length or the base is also in milliseconds. So what would that be? So the average, the V average value, or the average voltage value, will be 2 out of 2 times 10 power negative 3. This is times 10 power negative 3, and this will give us 1 volt. So the average value for this gives us what? 1 volt. And that's what is required. Let's look at another problem here. Number 2. So we are told that we have a plot of current versus time, and this is the shape that we have. We have it running from 0 to 1, then to 3, constant, then comes back to 0. So we are talking about, so if we are to look for the average value over half a cycle, then this is going to be, we need to look for area of half cycle. So this is going to be, remember this is a rectangle, and this other shape is also a rectangle. So it is made up of 2 rectangles. So this is going to be 1 times length by width. So 1 times 1, this one from here to there and to there. Then plus another area from here, from 1 to 3, the units are 2. So we'll have 3 minus 1. We multiply by a half from 0 to 3. So into 3 minus 0. So what is this going to be? This is 1 plus this is 2 times 3, and this is giving us 7 amp seconds. So that is the area. So the area is 7 amp seconds. What about the average? Average will therefore equal to the area under the curve divided by length of the base. And this is going to be area under the curve is 7. Length of the base is from 0 to 3. So 3 minus 0. So this is going to give us 7 out of 3. And therefore, we'll have that the average current will equal to 2.33 amps. So that is going to be the average. So meaning that your average is going to be lying between, let me use a different one. So this is going to be your average around there, okay? And that will give you the average value of this function over half a cycle.